magnitude, what is the magnitude current flow in the wire I2 and direction, right? What is the magnitude and direction of the I2 when the magnetic field at the point P at the point P is equal to 0. At the point P now, you have two magnetic field. The first magnetic field is come from the first wire number 1, and this is direction of the magnetic direction of the B here is this is magnitude of, this is direction of the current flow, right? The direction of the current flow is into the page. So now if you use a right hand here, the direction of the, so now if you use the direction current flow into the page here, so right hand, the direction of the B is okay like this. And so now the magnetic field B from the wire 1, right? So wire 1 to the point B here, this is into the left, right? And now the B, because of current I1, so let's say this is B1 is equal to, equation to calculate the B is a nu naught I here is I1 divided by 2 pi, and the distance here R. So now the value of the nu naught is constant, 4 pi exponent minus 7, right? And this is the I1 is equal to 6 ampere, right? This is 6 ampere, and the distance from wire to the point P here is a 0.5 and 1. This is a 1.5 meter, right? This is 1.5 meter. So now you can find the value of P1 is equal to 2 ampere. Sorry, P1 is equal to, okay, oh, no need for you to calculate the final answer first, because to find the value B at the point P, so that the total P at the point P is equal to 0, right? Or is equal to 0, meaning you have a 2B. The first B come from the wire 1, and the second B is come from the wire 2. But because the BP here is equal to 0, meaning you have the same value of B, B1 and B2. So meaning here the B2 is also, you can use the same, this is I2 and this is 2 pi R, alright? But to make the B here is equal to 0, you must have another B here, the same magnitude but opposite direction, meaning the current I2 must produce B, this is B2, opposite direction, same magnitude and but the opposite direction. That's why the at the PB is equal to BP is equal to 0. So meaning here you have a B1 is equal to B2, and from the B1 you can find the value of the, I can use here the value here. So you have a nu naught I1 is equal to 2 pi R, and you have the value of this is equal to B2, and so if you calculate here, so can you see here, this is equal to nu naught I2 is 2 pi, this is R1, this is R2, so you can cancel here, right? And 2 pi is, so now you have I and R only, so I here is 6 ampere and the distance is 1.5, and here is a I2, and this is R2 here. From I2 to the point P is a 0.5. So now you can find the value of the I2. So if you calculate I2 is equal to 2 ampere, and the direction of the I2 is to the right. It must be opposite direction to the magnetic field produced by the I1. Next question is what is the magnetic field at the point Q? So at the point Q, as you know, you have a 2B. The first B is come from the wire 1, and the second B is come from the wire 2. So the first is B from the or B1. B1 from the wire 1 is equal to equation u naught I divided by 2 pi r. This is for the 0.5 distance from wire 1 to the point Q, r. This is R1, and B2, same equation, nu naught. This is I1, right? This is I2 divided by 2 pi r2. Distance here from wire 2 to the Q is 10 plus 0.5 meter. So now if you find the value of the, so nu naught is constant, 4 pi exponent minus 7, and I2 I1 is equal to 6 ampere, and the R is a distance here 0.5. So you can use the value of R. For the R2 is 1.5, right? 1.5, and the I2, this is answer from you can use answer number 1. This is 2 ampere, and you note the same value here. So if you calculate, the B1 is equal to 2.4 exponent minus 6 Tesla, and the B2 is equal to 0.27 exponent minus 6 Tesla. So now you have 2B, B1 and B2 at the point Q, but the direction, so first direction for B1, so the B1 you can use the right hand, so direction of the I upwards, so your thumb direction to the upward, so direction of the B produced by the wire 1, okay, into the left here, so this is to the left, and B produced by the wire I2, the direction from the answer number 1 is sorry, this is direction I1 into the page, meaning direction here is to the right, to the right, okay, and wire 2 into the page. This is from answer number 1, into the page, meaning direction produced by the wire 2. Sorry, this is out the page, so meaning direction is to the left. So meaning at the point Q here, the B1 produced is because current into the page, so this is direction to the right, and the B2 here is to the left, so meaning the total B at the point Q is equal to B1 plus B2, but and the one you can use the, let's say the B1 is 2.4, right? 2.4 exponent minus 6, and plus, because B2 to the left, so you must use a negative. This is 0.27 exponent minus 6, right? Okay, so the BQ here is equal to 2.13 exponent minus 6 Tesla.